Hi class, let's take a look at this problem here. We have some pairs of data with an alpha 0.05 and we wish to determine the correlation. So let's use StatCrunch to do this. So here's StatCrunch right here. Go to Stat and then we want to go to Regression, Simple Linear. The X variable is var1, the Y variable is var2. And let's move this up and compute. And here is my output right here. Here is my correlation coefficient. And here is my regression equation. And if I flip to the second screen, I can see that I have a scatter plot. So the correlation, is reported right here, 0.911. So now what we have to do is we have to determine, is the correlation meaningful to me? Okay, in other words, yes, 0.991 is pretty darn close to 1. And yes, intuitively, I would think that this has to be a pretty strong regression, or a pretty strong correlation, I should say. But we have to remember that behind every correlation is a hypothesis test. So just like we have critical values for normals and t-statistics, etc., so on and so forth, we also have critical values for correlations. So what we have to do is we have to recognize that we have 1, 2, 3, 4, 5, 6 pairs of data. So that means our degrees of freedom are going to be 6 minus 2, or 4. And we have an alpha 0.05, and if I click on my critical table here, this one's actually configured for sample size, so it makes it even easier for me. So in this case here I have 6 pairs of data, and alpha is 0.05. Therefore, the critical correlation is 0.811, and we need to recognize that there are 2 values. Every correlation hypothesis test is a two-tailed test. The null is the correlation is 0. The alternative is that the correlation is not 0. So therefore, these are magnitudes of critical values for each alpha compared to a sample size, a sample of pairs. Okay? So that's where the 811 number comes from. So the decision is basically the same as it's always been. I compare the critical to the test, or I compare the p-value to the alpha. In this case, I'm going to compare critical to test, because the absolute value of the linear correlation coefficient, okay, which is 911, is bigger than the positive critical value. So in other words, it's not within the realm, is not within the range of negative 811 to positive 811. So it's outside that range, okay? There is sufficient evidence to support the claim that the linear correlation between overhead widths of seals from photographs and the weights of seals is significant. So that is indeed correct. And that is it. Thank you.